In this video, we learn the specificity or selectivity analytical method validation performance characteristic as a part of video series Analytical Method Validation, Fitness for Purpose of Analytical Method. If you are not watching previous video, please find in above card. Hello, I am Biren Godasara and you are watching Intelligent Learning. The true sign of intelligence is knowledge but imagination. In this video we imagination. What is specificity or selectivity? What is effect of interference? Different types of interference effect. Selectivity assessment for qualitative analysis. Selectivity assessment for quantitative analysis assay test. Selectivity assessment for quantitative analysis impurity test. Performance acceptance criteria of selectivity. What is specificity or selectivity? As per ICHQ2 guideline, specificity define. Specificity is the ability to assess unequivocally the analyte in the presence of components which may be expected to be present. Typically these might include impurities, degradants, matrix, etc. As per International Union of Pure and Applied Chemistry define selectivity. The extent to which the method can be used to determine particular analytes in mixture or matrices without interference from other components of similar behavior. Definition of various documents more or less agree with this interpretation, while International Union of Pure and Applied Chemistry recommended the term selectivity, while pharmaceutical sector use specificity or analytical specificity and diagnosis specificity as used in laboratory medicine. What is effect of interference? The concentration of an analyte is normally not measured directly. Instead, a specific property, example intensity of light, is quantified. It is, therefore, crucial to establish that the measured property is only due to the analyte and not to something chemically or physically similar, or arising as a coincidence, thus causing a bias in the measurement result. So to perform selectivity to evaluate the ability of a method to respond only to the target analyte in the presence of other components expected to be present in the samples. Different types of interference effect. The main two types of interference effect: proportional effect or rotational effect. Translational or fixed effect. Proportional effect or rotational effect. Interferences may cause a bias by increasing or decreasing the signal attributed to the measurand. The size of the effect for a given matrix is usually proportional to the signal and is therefore sometimes called a proportional effect. Interferences may cause changes the slope of the calibration function, but not its intercept. This effect is also called rotational effect. A translational or fixed effect arises from a signal produced by interferences present in the test solution. It is independent of the concentration of the analyte, due to as a background or baseline interference. It is called translational or fixed effect. Translational or fixed effect affects the intercept of a calibration function, but not its slope. Selectivity assessment for qualitative analysis. In the case of qualitative analysis, identification tests, the ability to select between compounds of closely related structure that are likely to be present should be demonstrated. Experiment of qualitative analysis should perform single time. Analyze test samples and reference materials. Analyze reagent blanks and blank samples, in other words samples containing matrix components but none of the analyte of interest. Analyze materials structurally similar to or closely related to the analyte. Evaluation of the data. Analyze test sample and reference samples given the positive result or response to evaluation by comparison of test sample and reference materials. To confirming that blanks given the negative result or response. To confirming that a positive response is not obtained from materials structurally similar to or closely related to the analyte. For example, spectroscopy. In infrared spectroscopy, identification of unknown compounds may be made by matching absorbance signals, in other words peaks, in the analyte spectrum. Once it is believed the correct identification has been made, a spectrum of reference of the analyte should be recorded under exactly the same conditions as for the test portion. The larger the number of peaks which match between analyte and reference material, the better the confidence that can be placed on the identification being correct. It would also be worthwhile examining how dependent the shape of the spectrum was with respect to how the analyte was isolated and prepared for infrared analysis. For example, if the spectrum was recorded as a salt disk, the particle size distribution of the test portion in the disk might influence the shape of the spectrum. Selectivity assessment for quantitative analysis assay test. For qualitative analysis, the evaluation of the selectivity the experiment plan should be done for assay test in single-time analyze test samples and reference materials. Analyze reagent blanks and blank samples, in other words samples containing matrix components but none of the analyte of interest. Spiking a known amount of possible or suspected interference to representative test samples, at levels expected to be found in the test samples. For multiple possible interferences, consider a ruggedness study to screen for the effect of a number of interferences by applying stress conditions, example, light, heat, humidity, acid-base hydrolysis, and oxidation. Evaluation of the data. Analyze test sample and reference samples given the positive result or response to evaluation by comparison of test sample and reference materials. To confirming that blanks given the negative result or response at our interest. To confirming that the assay result compared with the presence of these extraneous materials. In ruggedness study, the assay results should be compared. Selectivity assessment for quantitative analysis impurity test. For qualitative analysis, the evaluation of the selectivity the experiment plan should be done for impurity test in single time. Analyze test samples and reference materials. Analyze reagent blanks and blank samples, in other words samples containing matrix components but none of the analyte of interest. Spiking a known amount of possible or suspected interference to representative test samples, at levels expected to be found in the test samples. In case of impurity not available, consider a ruggedness study to screen for the effect of a number of interferences by applying stress conditions, example, light, heat, humidity, acid-base hydrolysis, and oxidation. Evaluation of the data. Analyze test sample and reference samples given the positive result or response to evaluation by comparison of test sample and reference materials. To confirming that blanks given the negative result or response at our interest. To confirming that the impurity result is unaffected by the presence of these extraneous materials by evaluation of accuracy and precision. In ruggedness study, the impurity profiles should be compared. Example chromatography. A peak in a chromatographic trace may be identified as being due to the analyte of interest on the basis that an reference material containing the analyte generates a signal at the same point on the chromatogram. But, is the signal due to the analyte or to something else which coincidentally coelutes, in other words a fixed effect? It could be either or both. Identification of the analyte, by this means only, is unreliable and some form of supporting evidence is necessary. For example, the chromatography could be repeated using a column of different polarity, employing a different separation principle to establish whether the signal and the signal generated by the reference still appear at the same time. Where a peak is due to more than one compound, a different polarity column may be a good way of separating the compounds. In many cases, modern mass spectrometric instruments can offer a high selectivity, example gas or liquid chromatography with mass spectrometric detection. Peak purity tests may be useful to show that the analyte chromatographic peak is not attributable to more than one component, example, diode array, mass spectroscopy. Performance acceptance criteria of the selectivity performance parameter 2. Demonstrate that other components likely to be present in the test samples do not affect the measurement results. Confirmatory techniques can be useful as a means of verifying identities. The more evidence one can gather, the better. Inevitably there is a trade-off between costs and time taken for analyte identification, and the confidence with which one can decide if the identification has been made correctly. User can decide how much supporting evidence is reasonably required to give sufficient reliability. If detection or quantification is inhibited by the interferences, further method development will be required. Keynotes of this video. Selectivity to evaluate the ability of a method to respond only to the target analyte in the presence of other components expected to be present in the samples. Interference effect are proportional or rotational effect and translational or fixed effect. Qualitative analysis experiment test sample, reference material, blank, structurally similar to or closely related to the analyte. Quantitative analysis experiment test sample, reference material, blank, spiking impurity, ruggedness stress study. Acceptance criteria. Other components likely to be present in the test samples do not affect the measurement results. Question of this video. Method published by standardization bodies need to demonstrate selectivity. It does not need to evaluate. B. Fully describe selectivity. C. Partially describe selectivity. D. None of above. Please give an answer in comment section. Thanks for watching. Hit the thumbs up if you enjoy. Share this video for your friend and colleague. How you feel for this video, please comment below. Do not forget to subscribe for update. And see you in next video.